Hello everyone. So today in this video we are going to look into a new theory, and that is valence bond theory. Now you might be wondering, we already tried to discuss VSEPR theory. Now why we need another theory to understand chemical bonding? That is because there is a reason. There are a lot of drawbacks when it comes to VSEPR theory or the understanding of chemical bonding via VSEPR theory. If we look closely at the VSEPR theory, it's more of an empirical approach to chemical bonding. That means it is on the basis of some kind of experience and some kind of understanding we are predicting the chemical bonding between various atoms. But there is no kind of theoretical or experimental backing for the VCPR theory. So that's why it can be said that it is more of an empirical approach to understanding of chemical bonding. And another drawback with the VSEPR theory is that it does not explain why bonds exist between the atoms. That means it do talk about the octet concept on the basis of Lewis theory, but still it is not sufficient enough to support the fact that why does the atom actually come together and form the bond. That means the background behind the bond formation is still not very much clearly understood when it comes to VSEPR theory. Further, we know that atoms are made up of atomic orbitals, and we have looked into detail when we talked about the atomic structure. And so when we talk about the valence shell electron, these valence shell electrons are actually occupying the atomic orbitals. So whatever chemical bonding is happening, there must be some degree of atomic orbital involved in this chemical bonding. But that particular concept is not being utilized when it comes to VSEPR theory. So we have a question now that how this can be understood in a more elaborate and a more understanding way. Okay, so that part is what is taken care of partially by this theory called valence bond theory. Now you might have already learned about valence bond theory in your school level. Okay, so we would some of the things that I'm going to talk about in this valence bond theory is something that you have already have the knowledge about. Okay, so what is the valence bond theory? So valence bond theory basically take into consideration the valence atomic orbital or valence shell atomic orbital, and here what we are talking about is the combination or overlap of the valence orbital of one atom with the valence orbital of the other atom that is forming the bond with the first atom. Okay, so here we are introducing the concept of atomic orbit. Okay, and when these atomic orbital kind of overlap between the two atoms, it leads to the formation of what you called as the covalent bonding. To understand it more clearly, let us talk about the H2 molecule, so hydrogen molecule. When we talk about hydrogen molecule, we know hydrogen comprise, if we talk about the electronic configuration, it is 1s1. Okay, so there are two hydrogen bonds, atom which are forming bond with each other. So each is a 1s orbital. They combine with each other to overlap, okay, and form a covalent bond. So valence bond theory talk actually about the valence atomic orbital kind of overlapping with the other valence atomic orbital of the other atom. So if we talk about another example, that is HCl. So here basically if we talk about the valence orbital that is involved in hydrogen, it is 1s, and when we talk about chlorine, if we talk about the electronic configuration, chlorine is basically neon, so 3s2 3p5. So this is the valence shell. Okay, and in the valence shell 3s2 is completely filled, 3p, there is one of the subshell is having, one of the orbital in the p subshell is only singly filled. Okay, so that particular p orbital can overlap with this singly filled 1s orbital of the hydrogen. So that is what is shown here. So 1s orbital of hydrogen kind of overlap with the 3p orbital which contain the unpaired electron, and they form a bond here. So this overlap that happens between the atomic orbital of one atom with the atomic orbital of another atom, okay, is what we consider in the valence bond theory. So here basically what is happening is that when the bond is formed, it leads to the formation of the covalent bond in the chemical bonds. Okay, so I hope you pretty much understood what we are talking about. Now here again, when we talk about a chlorine molecule here, so it basically involves the combination of two 3p orbital of the chlorine. They overlap to form a bond here, and this overlapping lead to the formation of the chemical bonding or the covalent bonding in covalent compounds. Okay, so this is an important concept that is introduced here in the valence bond. So valence bond basically means here we are talking about chemical bond that is formed as a result of overlap between the atomic orbitals. Now, important thing that you have to consider here is the overlap will happen only with those orbitals which contain single electron. Okay, so this 3p orbital of the chlorine is contained a single electron, and this 1s orbital of the hydrogen atom contain one electron. Therefore, they can overlap, leading to pairing up of this single electrons, leading to the formation of a covalent bonding. So the paired electron leading to a chemical bond in the Lewis structure is what is clearly explained here when it comes to valence bond theory. That is more we can realize in terms of the atomic orbital when we talk about valence bond theory. Now, moving further into another important thing that you have to here come to understand is the bond length. So we know that whenever a compound is formed between the two atoms, the distance between the two atoms is what we consider as the bond length. So when we talk about the hydrogen molecule, so 1s orbital, they overlap to form the hydrogen molecule. So what is the distance between the two nuclei is what is called as the bond length of that particular hydrogen molecule. Now, if we consider this particular energy diagram, so when these hydrogen atoms are far away from each other, what you find is the potential energy of the system is completely zero. There is no kind of interaction that is happening when they are far apart from each other. However, when you try to bring these two hydrogen atoms closer and closer, what you see is a decrease in the potential energy. Now, why this is decreasing? This is because there is a kind of orbital overlap that is happening, and there is an attractive interaction between the nuclei of one atom and the electron cloud of the other atom. So that all factor is leading to a decrease in energy, and as soon as it comes to a particular value, like in the case of hydrogen molecule, it is 0.74 angstrom, after which you further try to bring them closer, the potential energy soon increases drastically, and that is because now if you bring these two hydrogen atoms further closer than 0.74 angstrom, it will lead to electrostatic repulsive interaction between the two nuclei. So this minimum distance at which the energy of the system is almost to a very low value, this distance is what we call it as the bond length. So at this distance where there is a balance between the attractive force of the nucleus and the electron and the repulsive force between the like charges, that is nuclei of the one atom with the nuclei of the another atom. So when there is a balance between the attractive and the repulsive forces, that distance is what we call it as the bond length. Okay, so when we talk about the valence bond theory, when we talk about the atomic orbital, there, this is how we try to understand the bond length concept when it comes to chemical bonding. For every covalent bond, there is a particular bond length, and that bond length is the minimum distance at which the attractive forces and the repulsive forces between the two atoms balance each other, or they are in equilibrium. That distance is referred to as the bond length in any covalent compound. So that is all about the basic understanding about the valence bond theory. So I hope that you understood why there is a need to bring in this concept of valence bond theory, because BSCPR couldn't talk in terms of more realizable things like atomic orbitals. It was just an empirical idea of experience. Okay, these molecules might be having this kind of shape on the basis of just empirical Lewis structures. Okay, so it wasn't a very comprehensive idea about the chemical bonding. So we required something more deeper, okay, which involves some kind of atomic orbital. So valence bond theory basically talks about the overlap between the valence shell atomic orbital of one atom with the valence shell atomic orbital of the other atom with which it is combining. And this overlap that is happening is what is leading to the formation of a covalent bond in covalent molecules. And another important thing that we have to remember here is the overlap between the valence shell will take between that orbitals which contain single electron, not between any other orbital. So if the orbital is already containing 2 electrons, it won't participate in formation of bonds. So it is important that the orbital that are involved in chemical bonding, it should be occupied with single electron. So with that thing in our mind, we have got a brief idea of what valence bond theory is. Now in the next video, we will be talking about the application of this valence bond theory into explaining the structure of the various molecules. So with that, I would like to close this video. Thank you very much.